All right. Someone has requested number 3 from the handout I gave out in class for chapter 5.4. So that would be solving trig equations, number 3 on the very bottom of the extra handout. If there's some ambient sound in the back, that would be my children. Please excuse the distraction and see if you can focus on the important things, which is this question. So number 3, looking at this, I don't have the answer key next to me, but I thought it would be more, uh, it's more pressing to actually get a video out there. Looking at this question, I think the first thing I would do is either try to get all of this into a single trig ratio with the angle 2x, or use some identity to get rid of the 2x altogether. I'm going to fool around a little bit to see. So this is like sine 2x. That would be 1 plus cos 2x. Let's see, or sine 2x minus. I could use an identity, but either way, if I do, that becomes 1 to the x. Okay, you know what? I am going to use the double angle formulas to see if I could change this into something else. So sine 2x minus cosine 2x equals 1. I am going to use the double angle formulas, turning sine 2x into sine x cos x minus, and this is cos squared x minus sine squared x. Um, and I have a feeling that I have to do minus 1 here. Next. Oh, I think I found something. I'm gonna expand this. So this is 2 sine x cos x. And again, the reason I say I found something is because I have seen these kinds of questions before. What I noticed was that I have a sine squared, I have a cosine squared, and I have a term that's 2 sine and cos together. That, to me, through all of my practice from factoring, looks sort of like this. It sort of looks like x plus y times x plus y. That's why I'm trying it. So multiplying, I can rearrange this saying sine squared x, right? Um, 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 Actually, yeah, sine squared x plus 2 sine x cos x minus cos squared x equals minus 1 equals a 0. Does that help me? No, actually. If I wanted to factor this, they would both have to be a negative. So maybe the -1 has to, I'm still a believer that this is supposed to be factorable. So I'm gonna see if that -1 can be, rewritten as negative of cosine squared plus sine squared x. And if I do that, this becomes mm, hmm, then this becomes negative sine squared x. That subtracts with this. And so this becomes a negative 2 cos squared x plus 2 sine x cos x equals a 0. A cos could be factored. I'm going to factor out a negative cos, giving me a positive cos x minus a sine x. And I think I can work with this. I can say that technically, because a product of two terms equals a 0, that means cos x must have been a 0, or this bracket cos x minus sine x must be a 0. So I have two cases. Case number one, oh my gosh. Case number one, I'm going to test to see what angles make cos x equal a 0. I'm also going to test case number two, where cos will equal a sine. Okay? And if I think about this from a graphic perspective, in a interval of 0 to 2 pi, I should have two angles at which, oh my gosh, sorry. You're gonna have two angles at which cosine equals a 0. So from here, I should get two answers. Okay? And here, I'm simply gonna, just graphically, I'm gonna guess Cosine is, I'm going to use a highlighter. Cosine is bam, 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 bam for 2 pi. And then sine is bam, 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 bam for 2 pi. So even here, in an interval of 0 to 2 pi, I should get myself 1, 2 answers where cosine and sine are equal to each other, which makes sense. From case 1, I get 2 of these answers, and from case 2, I get the other 2 of these answers. See if that is enough. Pause the video, give yourself a chance to try it. Um, yeah, assuming that you've tried it, cosine x when it equals a 0, x must be pi over 2 or 3 pi over 2. When does cos x equal sine x? Well, um, you know what? The best way to do it is 1 is equal to sine x over cos x. So 1 is equal to tangent. And so that's going to be in quadrant 2 and 3, 1 and 3. That's going to be an angle of pi over 4 and 5 pi over 4. Okay, so pi over 4, 5 pi over 4, pi over 2, 3 pi over 2. You got it. Hope this is clear enough. A question like this, if you have to use identities to actually solve it before you get the answer, that would be a harder version of an A question, or borderline, it would basically be a T question. Something like that, I'd probably give it to you as a T. Either way, study hard, keep on working, and I hope this helps.